Hello guys, in this video we will learn how to model a water tank in SAP 2000. To start with, I will start by new model, selecting blank, then edit grid data, making sure that the units are kilonewton meters, then edit grid data, modify. This is the figure of the water tank, therefore we will try to define 4.92 in X and Y direction since it's a squared, and then the heights. Therefore, I will try to, first of all, we should define the 0, 0 in all the directions and then press spacing. Now in X direction, we must again press, since it will end in 0, therefore this one is, how much is it? A is 4.92. Then in Y direction, it's again 4.92. Then in Z direction we have 3 heights, therefore it will end in 0, starting by the first one, which was 5.31, and then 5.31, then it will end with 5.01. Yes, now press OK. Again, yes, restore the 3D by this one, set default 3D view. This is the grids. Then we will define the materials first. It was mentioned there, we will use 25 unit weight of the concrete, and the E measures resistivity 32,000 megapascal, and then we will multiply it by 1000 to make it in gigapascal. And now this is 25, the name of it concrete, yes, and then the E will be 32,000, yes, and then adding 3 zeros again, yes, this is it, and then OK, press OK. Now define the section properties, frame sections. Here it was defined that column must be 40 by 40 centimeters, tie beams 40 by 40 for this one, and bottom slab and top slab 10 beams. So we will define our frame sections, which are the beam, tie beam, and the column. Therefore, I will try to add a new property, rectangular, which I will name it as column, which is 0.4 by 0.4, and then the material is concrete. Okay. Then add copy of property. We can name this one as tie beam, and it was 40 by 40 again, the tie beam, 40 by 40 centimeters. Therefore it's concrete, but we can change the concrete reinforcement to beam here. This is for the aim of design, so but for the analysis it's not important. Okay. Then add copy of property of the tie beams. Now we can name this one as beam, which is 0.90 by 0.40, 90 by 40. We are done with the frame sections. Now section properties, area sections. Now we have, in area sections we have roof, slab, which is roof means the top slab, and slab means the bottom slab. Here it's defined bottom slab. Then the walls also. Walls are the walls of the tank actually. Therefore, for the bottom slab it must be 30, then the top slab 15. Add a new section. Let's say top slab it was 15, and here 0.15. The material is concrete. Then press OK. Add copy of it. We can say now bottom slab, which is 0.30 by 0.30. Let's say OK. Add copy of section. Again, we will name this one wall. Let's say wall. And how much is it? The thickness 0.25. Therefore 0.25 by 0.25. Yes. Okay, we are done with all the defining all the things we needed. Now I will try to draw the walls of the tank, and then the bottom slab and top slab, and then assigning the pressure. Since it's easier, at the end we will add the columns and frames. So I will start by the upper part. Now let's say in XZ view, I'll try to draw the walls by taking the rectangular area draw tool. Now we can select wall. Then going to the next Y, which is A by A, we will go 4.92 to the other side, which is from here. So yes, again draw one here. Then changing the elevation view, YZ view, drawing one here, and then one here. Yes, we are done with it, with the walls. Now XY view, this is the Z0, this is H1 5.31, and then again 5.31. Now we are at the bottom of the reservoir. Then we will say draw the bottom slab, and then going upward, now we will draw the top slab. Yes, here we are done with it. Then I will select everything. I will select all the areas, selecting by properties, all the areas, area section, bottom slab, let's say, top slab, and walls also, close. Since I have selected all of them, then I will say divide areas. By dividing the areas, here it's mentioned that divide the areas 0.5 by 0.5, the mesh. Therefore, I will divide them 0.5 by 0.5. Yes, apply OK. Yes, this is the mesh. Now I will try to select by properties all the walls. Oh, sorry, no need for this one. Actually, we must select them with the joints. Now this time we will select everything with the joints. Select this one, then change the elevation view, select everything with the joints, only for the walls. Now we will say define, before leave the selection, now define the joint patterns. We will add new one, changing the name here. We will say water pressure, add a new pattern name. Okay, then yes, now we will go again to the define load patterns. We will say again water pressure. Yes, type, let's say other, self weight multiplier is 0. Now OK. Since we have the selection, all of it, if you can make it 3D, it's only the walls. Now we will say assign joint patterns here, and then since the pressure will be applied in Z direction, depending, I mean it will depend on Z direction, since the water is in Z. When you go downward or upward, it depends on the Z for the pressure, since it has triangular pressure distribution. Therefore this is in Z direction. So we will say how much is all these summations, all these numbers. We will say 5.31 plus 5.31 plus 5.01. How much we will get? Yes, this one, 15.63. Therefore I will put 15.63, or how much was it? Yes, 15.63. I will put it in constant D, 15.63, since we assume now the water tank is at the top, full, all the tank is full. Then this constant C, since it relates to Z, we will assign it as -1 to let the pressure be applied in the from inside to outside. And now we will select water pressure, and now press OK. Yes. How we can check our assigning is correct? Actually, this one 5.01, you must get the H2, yes, the highest depth, since here we will have the highest pressure. Okay, then I will say now again get the undefined shape. Now we are done with the assigning. All these are the z values. Now we will assign the gamma water, actually gamma water of the since the tank is full with water, which is 10. Now we again say select get previous selections. Now assign area loads surface pressure. Now surface pressure, I will select water pressure. We will say bottom loaded phase is bottom phase. Then by joint patterns, then since we have defined all the joint patterns, and now I will put 10, not 110. Yes, and press OK. Yes, as you can see here, the water pressure distribution is triangular. You can see here, but this is wrong actually. Why it's wrong? Because it's outside. It must be from inward, outward, from the inner face of the tank. So here we will change it now, and from the other face also. So these faces are in the YZ. In the YZ, I will change this one. In the YZ actually, and in the XZ, but in that side from the other side actually. Now I will press this one and say YZ first. We should select this one at x equals to 0, and then again assign area loads pressure, and then changing this one to -10 to make it from the inner face, and say replace existing load. Okay, when you press 3D now, yes, you see it disappears and then it goes inside. Now for that side also we will do it by taking XZ elevation and changing the Y XZ, and now this is Y equals to 0. No, it must be Y equals to 4.92. Selecting it again and say assign area loads pressure, yes, and -10, and replace existing load. Okay, now when you press the 3D view, we will see all the pressures are inside now. Yes, all of them inside. Yes, undefined shape. Now we will say the elevation. We will try to draw the columns and everything. Now column, this one is column. Now I will take the tie beam. Yes, and draw one beam here. Yes, now going next, this is the beam again, changing this one to tie beam, also the column. Yes, changing the elevation view. No, this is XZ now, and this one is YZ. I will draw one tie beam here and one beam. Oh, sorry. And here one beam again and tie beam here. Yes, 3D view. We are done with all these, and then try to make it like this, selecting all the nodes here, and then assign joint restraints fixed. It was mentioned there, use fixed, since yes, this is the shape of it, so it will be fixed. Now 3D, what is left is to define the load combination, since they are asking us to only define load combination, which is the water pressure and the dead load. So define load patterns. We have defined already the water pressure. Load combinations, add a new combo. We will say DL plus WP means the water pressure, or we can write water pressure linearly. Scale factor is 1 for both. Okay. Now we are done with it. We can save it. Then we will run the analysis. New folder, we will say water tank. This one is, let's say, water tank. Yes, Yes, it is saved. Now run analysis and yes, waiting the result. Actually, one thing we have forgot to add is, I will again unlock the model. We have forgot the one thing is, since we have water here in the bottom slab, we will have uniformly distributed pressure. I mean, if we have this one, actually to the bottom we have a uniform pressure on the slab like this, so it will be uniform. Therefore I will try to add all these. Yes, it will be uniform to the bottom here. Therefore, and its magnitude will be H2 multiplied by gamma water. Yes, this one will be the magnitude of it. So how much it will be? 5.02. So it will be 50.1 to the bottom slab. So I will go again to SAP and then press XY, going downward to this one. Yes, this is it. I will try to apply to this one. So this select the frames, I mean the beams actually. These are the beams, and then say assign area loads pressure, surface pressure. But this time it will not be by joint pattern, it will be by element, and it is 50.1. And it will be negative since it will be to the downward, not upward, so it will be negative and bottom. Okay, then if we press this 3D view, you will see 50, negative 50, negative 50. These are the perpendicular actually. Yes, so now we are done with all the defining all the definitions actually. Now I will say again on the form and then run the analysis again. Yes, this is the dead load deflection caused by the dead load only. This is dead load and the water pressure. You can see it like this. Yes. Now again I will go to display, show forces, shells. Actually I can select it from here, shells. We can see the M11 and selecting dead load plus water pressure. This is the M11. We can zoom in and then file, print the graphics. We can print it. Now this is one of the requirements, the M11 diagram. We can print it from here. Then we can also select M22. Actually, okay, this is M22 diagram. What else we can select? Here it's mentioned print axial forces, shear forces, and moment diagrams. M11 and M22 we are done. Now we need the axial forces and shear forces. Therefore here we will select frames, and then I will say dead load plus water pressure forces shear 2 2. This is the for the axis. We can press the elevation view, zoom in a little bit. I can change some of the options, show values to see the values of it. Press OK. Yes, or we can add, since the scale is small, we can say user defined, use 0.001, let's say, and let's try to see it. It is so small, we can change it a little bit, say 0.009, and yes, here we can see the results. Or by pressing right click on it, on the beam, we can see this is the diagram and all the values we needed. Done. Therefore this is the shear diagram. We can print it again by printing graphics, or sorry, not shells, actually frames. We can change this one to 5, let's say 0.05, and yes, somehow it's too much, but at least we can see it more easily. Print graphics, we can see it here. These are the values. We can print these for the submission, and then we can say moment 33. Okay, this is the moment again. We can print it directly. Here it's more clear to see it. What else? The axial force also, it is too big since it's high for the one, since the columns are holding the water tank. So I'll try to reduce the scale 0.01, let's say. Yes, it's more readable like this. Again, we can print the graphics, and then we are done. This is it. Thank you for watching. Hope you get the benefit from this video. Wish you all the best.